Okay, so these are going to be notes on sector area as well as composite figures. First, the sector area is going to go by pretty fast. I'll be asking you to go ahead and plug things into your calculator, figure out. It literally, you just plug two numbers in and you solve. It's going to be great. First of all, we talk about a sector is an area, and it's going to be bound by two radii, plural for radius, of a circle and its intercepted arc. You can see, even in the picture here, the sector area is going to be the area of the sector. It's going to be, we're looking for the area, that shaded area, that shaded circle. Now, the formula for sector area, there is a proportional way of setting it up, just like when we talk about arc length, but we're going to go ahead and use a simplified version of the formula where the area is going to equal, we're going to have pi times theta times r squared over 360. Remind ourselves that this theta is going to be the central angle, and r, as we've known for a very, very long time, is going to be your radius. Now, because we're using pi, we are going to use the pi symbol, not 3.14, not 3, okay? And because we're using pi, we're going to end up with a decimal, so we're going to run to the nearest tenths on all three of these. The first one we have here, we're going to look at our picture. We're going to notice that right here, our radius is 6. And our central angle is going to be that 120. So these are what we're going to plug into that formula. So we have area equals, it's going to have our fraction bar. We're going to put in pi. Then we want theta, it's 120, times the radius squared. Make sure that we are putting that radius 6 squared in there. You forget to square it, you will get the wrong answer. Okay? And we can just plug all of this in at the same time in the calculator, making sure we're very, very careful. Go ahead and take a moment and pause, plug that in, and figure out what that answer is on your own. Rounded to the nearest tenths, we should have come up with 37.7. All right, the next one. We're seeing here that our radius is 3. Our arc, AB, is 20, but we remember your central angle and your arc are congruent. They have the exact same measurement. So your central angle will be 20. Plug into our formula here. We have pi times our central angle, 20, times our radius squared, so 3 squared, making sure that the parentheses are around the 3 and the squared, all over 360. Take a moment, pause please, get it written down, plug it into a calculator on your own. When we solve this, we should have come out with approximately 1.6. So I told you this is very, very quick. You just got to be careful that you're plugging the right things into the calculator. Here we're going to find the area, that is the sector that is outlined in bold. So we're looking for this whole area right here. Okay, again, round to the nearest tenths. So we're going to find that our radius right here is 16, and theta is going to be, where it shows this arrow right here, 240 degrees. I highly suggest that you pause it, set it up all on your own, solve it on your own, see what you get, and give you time to pause. So we have our area set equal to pi times our theta, 240, times our radius squared, that would be 16 squared, all over 360. If you haven't solved it on your own, pause, put it in the calculator, and we're going to come out with approximately 536.2. That's all sector area is. Plug in your radius, plug in your theta, plug it into the calculator. Let's take a look at composite figures. Your composite figures. What we need to know about the word composite, with composite figures, is we're going to have several different figures, okay, and they could be separated into regions of basic figures that we've looked at: squares, circles, triangles. So you have to, a lot of times you draw lines in to help figure out what shapes we have. We're going to find the shape, the area of the shaded region, and we're going to round to the nearest tenth. So we take a look at the first, number 1. It looks like somebody cut out a little half circle of a rectangle. So since we're cutting it out, that tells us we're going to have to subtract the area that's cut out. So to find this area, I'm going to put AT for total area, okay, because I'm going to start drawing in some shapes here. We're going to have the area of the rectangle, and we're going to subtract. Now, it's not a whole circle, okay? It is half of a circle. So we're going to take the area of the circle. Let me do that in a different color. Sorry about that. The area of a circle divided by 2, cutting it in half, okay? Giving us our area, plug in the formulas. The area for a rectangle is length times width, or base times height. And we're going to subtract the area of a circle divided by 2. Area of a circle is pi r squared. We're going to make sure that we divide that by 2. Okay? So here I'm going to have, and I didn't change colors on that one, sorry about that, base times height. Well, the base and the height are 50 and 30 on this rectangle. So I'm going to have my base times my height. I'm going to subtract my pi times radius squared. Well, we look over here, this whole entire length right here is 30. That's your diameter. If you just look at the circle, cut it in half, you've got 2 radii, given your radius is 15. Okay, so we're going to have pi times 15 squared all over 2. What I'm going to do real quick is I am going to, whenever I do the next step here, because of that circle, I'm going to wait to put pi into the calculator at the very end. 50 times 30 is going to give you 1,500. And we're going to subtract. If we take 15 squared, we're going to get 225. We divide that by 2. We're going to get 112.5, and I'm going to keep that pi symbol here. Now, when I do the subtraction, I'm going to take 1,500. I'm going to subtract 112.5 pi symbol, all in one step. Okay, do not forget to put that pi symbol in there. All right, and I encourage you to go ahead and do this on your own. Pause it. I already told you what to plug in the calculator. You're plugging exactly this into the calculator, and find your answer. Rounded to nearest tenths, we should have come up with 1,146.6. I'm not going to worry about putting units on there. The next one looks a little funky, but if you take a look at it, all I have here are 2 parallelograms. Okay? So we need to look at it this way. We're going to take, define that area. I think I lost a pen. Take that area. We're going to want to do 2 times the area of a parallelogram. All right? So that means we're going to do, the area will be equal to 2 times, and your area of a parallelogram is just your base times height. Okay? Now let's take a look at this. This whole entire length from left to right is 40. It's going to be split in half to give us each one of these sides because they're congruent. So that means this is going to be 20 and this is going to be 20. Now we have our base and we have our height. So plug in, we're going to have 2 of them. Our base, 20, times our height of 24. Please pause it. Do this calculation on your own. 2 times 20 times 24. That's all you have to do, and you've got your area. Please pause it. Our final area will come out to 960. All right, our next problem here. Let's take a look at what we have. Again, we're going to be split in half here. What we have are 2 trapezoids. All right, 2 separate trapezoids. They will be identical. Okay, so for one, we need to figure out what the height is going to be. Well, the height of both of them together is 64. Okay, so if we take that 64, we want to make sure that we take half of that 64, okay, to get 32. And this will be our height. Then we remember with our formula, okay, here it's going to write this in, we have area of a trapezoid. Well, here, our area is going to be equal to 2 times the area of a trapezoid because we have 2 of them. So it'll be equal to 2 times, we're going to have base 1 plus base 2 in parentheses times height divided by 2. And this looks really, really complicated. We just plug everything in. Okay, take a little at a time. So we need to remember our base 1 and our base 2. Okay, both going to be exactly the same. So let's just slowly plug everything in. 2 times, okay, up top, we're going to have, this could actually probably look a little bit cleaner if we just do a multiplication symbol right here. 2 times, so we're going to have a lot of parentheses, base 1, 20, plus base 2, 40, times the height, which we found out was, is going to be right here. This will be our height, 32, all divided by 2. So there's several different routes you could take here. These 2's will actually cancel out because you're multiplying by 2, then you're dividing by 2. So you're just going to be going back to exactly where you were. So you could look at it as this little fraction here. These are going to cancel out. So now all you're left with is your area is equal to just this right here. 20 plus 40 times 32. This 20 plus 40 will become 60. So now all we have is 60 times 32. Ways to kind of isolate some things here. And that 60 times the 32 will give you 1,920. All right, last one here. We don't have 2 of the same thing like we did on 2 and 3. We have a triangle and we have a square. How do I know it's a square? Because there's 2 congruent markings on all of these. So we need to go ahead and make sure that we're labeling some things here. This is also going to be 22. So this will be 22. Now they gave us from the tip of the triangle all the way down to the square as 42. Well, 22 of it right here is taken up with the square. So we take that 42, subtract that, so that we can find the height of our triangle. So the height right here of our triangle, I'm going to put H, little triangle symbol, is going to be 20. So I have everything we need now. Let's talk about the formula. This time we're not subtracting, we will be adding them together. So we're going to take the area is going to be, the total area will be the area of a triangle plus the area of the square. So let's take a look at these formulas. Area of a triangle is going to be base times height divided by 2. We're going to add the area of a square is simply just the side squared. Let's plug in. Your area, triangle, we have base, talked right here, at 22, times the height that we found, 20, divided by 2. We will add the square side length, which is 22 all the way around, 22 squared. A lot of 2's there. Now, if you want, you could do like a little cancellation here. And this, if we divide that 20 by 2, we're going to get 10. So then we just have 22 times 10. Okay. And then, so our total area, well, the area of the triangle is now going to be 220. If you don't like that cancel out, don't do it. Multiply 22 times 20, and you get 440 divided by 2. If that's the way you want to do it, please do it that way. And then we'll add 22 squared. It's going to give you 484. Last step, just add those two guys together. You're going to get 704. So with your composite figures, every problem's going to be different. So you have to take a look at it and see how can you split it up. Okay, what shapes do you see in the composite figures? Okay, if you have any questions, ask your teacher. If you are, when you work on your assignment, you have questions, how to break it down, make sure to ask questions.